Alright, in this video we're going to be talking about identifying linear equations in the first part, and in the second part we'll be talking about identifying x and y intercepts. So, starting with identifying a linear equation. Well, the most important part here is that you understand what a linear equation looks like. There are two forms that are generally used. The first is ax plus by equals c, and this is referred to as standard form. The second one, which is more common and you're probably already familiar with, is in the form of y equals mx plus b. And this form is called slope-intercept. Now, in order to identify a linear equation, we expect them to be written in one of these two forms. Notice neither form has any exponents, square root symbols, or any variables being multiplied together. Alright, so let's take a look at a couple examples. Looking at example number 1, we've got y equals 4 minus 3x. Now, this is really close to looking like y equals mx plus b. Notice we've got the 3x coming last, so we could simply rewrite that into y equals negative 3x plus 4, and you can see that that would be a linear equation. So number 1 is linear. Now notice in the directions it says, determine whether the equation is linear, then write the equation in standard form. This is not standard form. That was called slope-intercept form. In order to get it into standard form, it's going to need to look like ax plus by equals c. Alright, so we need to get this 3x over to the other side. How can we move that to the other side? Well, we can simply add 3x. It eliminates it from that side, and it moves it over to the other side. So we've got y plus 3x there on the left side equals, all that we have left, 4. Now, is this ax plus by equals c? Not quite. We need to do a little bit of shifting here, and because of the commutative property, we can simply move the side. So this becomes 3x plus y equals 4. Now it's truly in standard form. Alright, so that guy, number 1, was linear. Let's move on to number 2. I'm going to go ahead and erase all of this really quick. Looking at number 2, we need to decide if it is linear. Okay, we've got 6x minus xy equals 4. Now, if you recall, in the last slide I said that two variables can't be multiplied together. We can't have x times y, because we can't separate that to make it ax plus by equals c. So that means that this one is not linear. Alright, moving on, looking at number 3, we have 1/3 y equals negative 1. Most people, when they first see this, are going to think, well, there's no x, so it's not linear. Well, hold on. Let's take a look here. I can isolate the y, meaning get y alone. I'm going to do that by multiplying both sides by 3. y3, it's the reciprocal of 1/3, and 3 times 1/3 is 1. So we get y all by itself. So y equals negative 1 times 3 is negative 3. Alright, so we've got the y isolated. If you look at this equation, do you think that's linear? Well, it is, and I'm going to remind you why. If If you recall last year, we used something called y-Vux. Y represented a horizontal line with zero slope and an equation written in the y equals format. So because this equation is written y equals, this is going to be the graph of a horizontal line going through the point -3. Alright, so this is in fact linear. Alright, let's go ahead and try number 4 then. We've got y equals x squared minus 4. What do you think about that one? Linear or not linear? Well, because it says x squared, we're going to go with not linear. Linear equations cannot have exponents. That would make it a different kind of graph. Alright, let's go on to another problem. Alright, the next thing we want to look at is the second part of what I was introducing. We first identified whether it was a linear equation or not. Now we're going to identify intercepts of linear equations. We've got two kinds of intercepts. We've got the x-intercept, in which the x-coordinate of the point at which the graph crosses the x-axis is an x-intercept. So it's always going to be the ordered pair x, 0. For an x-intercept, our y value will always be 0. Same thing goes for a y-intercept. In a y-intercept, our x value is always equal to 0. I would jot that down. That's important information. The x-intercept always has a y equal to 0, and the y-intercept always has a 0 in the x. Alright, let's go ahead and take a look then at some examples. It says, find the x-intercepts of the line graphed at the right. Alright, let's go look. X-intercept, that's this guy right here. Looks like we're crossing at 20. So that one works, and that one works. Where are we crossing on the y-axis? Looks like we're crossing at 30. So the correct answer is B. It has both things correct. How about number 2? Which one do you think it is? Find the x and y intercepts of the graph. We got gym membership, total cost, number of months. Alright, where is it crossing the x-axis? It's not. So there is no x-intercept. The only thing we have is a y-intercept. It's crossing at 150. So the correct answer here is J. Making sense? I certainly hope so. Moving right along here, we've got one more example. This example here has both the table and the graph, so you can see how they're related. Let's take a look. It says a swimming pool is being drained at a rate of 720 gallons per hour. The table shows the function relating the the volume of water in the pool and the time in hours that the pool has been drained. Find the x-intercepts of the graph of the function. Alright. So if I look at the graph, I can easily see that on the x-axis, it's crossing at 14. So the x-intercept is 14 hours. Can you see that same place on the table? If you go where x is 14, notice that y is 0. So wherever there is a y value of 0, that is an x-intercept. So you can see it both in a graph and in a table. You won't always have both to look at. Alright, what about the y-intercept? Well, if we look at it in the table, remember, it's going to have an x value of 0. And on the graph, it's crossing the y-axis. So our y-intercept is 10,080 gallons. Alright, so we've identified the x and the y-intercepts. Now we need to describe what the intercepts mean in this situation. This can confuse people sometimes, but it's really not that difficult. The 14, the x-intercept, means that there are 0 gallons of water after 14 hours of the pool draining. That's the end. The starting point is over here. At 0 hours of draining in the pool, there were 10,080 gallons of water that needed to be drained out of the pool. Okay, so it's really important that you look at your variables in order to answer this question. The time and the gallons. It helped us to identify specifically what it means in this problem. Alright, so you are now able to identify x and y intercepts and identify linear equations. So what I'd like you to do for homework tonight is this problem, number 58 here. I'm starting with the harder one first so you can ask some questions. What you're going to do is you're going to draw a line on a coordinate plane with each of the following characteristics. So you're going to draw 5 graphs, one for each of these 5. Let's try the first one together. We're going to draw something that has an x and a y-intercept. Well, that's easy. There's a line that crosses the x-axis and the y-axis. I'm going to challenge you to draw something with an x-intercept but no y-intercept. Something with exactly 2 x-intercepts, something with no x-intercept and a y-intercept, and something with exactly 2 y-intercepts. Then in part B, you're going to talk about which ones you were actually able to do and which ones you were not able to do, and explain why. And then write a statement. What must be true of x and y intercepts of a line? All right, I'll erase all that mess so that you can see. Oops, undo. Here, erase that mess so you can see the problem exactly. There you go. So that's the first question in your homework, and then here's the rest of the question. You're doing 13 through 22 all. So in this first section up here, you're determining whether it's a linear equation, just like we did in the first example, and then you'll need to write it into standard form. Remember, that's ax plus by equals c. And then the last set, super easy. Find the x and y intercepts in both tables and graphs. Make sure you describe what they mean. Good luck, and we'll see you tomorrow.